Hey everybody, welcome back. So once again, we're going to be solving algebraically for an integral. So in order to solve this integral, we're going to need one, which we proved on the channel, and then two, just some really basic algebra. And so we want to prove the following. Quite a cool little integral. So we want to prove that the integral from a to b of f of x over f of x plus f of a plus b minus x dx is equal to b minus a over 2. So let's get into this. Okay, so the first thing that we want to note is that the original integral can be rewritten using that property that we mentioned just a moment ago. So let's go ahead and do that. So the integral from a to b of f of x over f of x plus f of a plus b minus x dx can be rewritten in the following way. Okay, so this is, so if I think about this whole thing as like my f of x or g of x, you can think of it like that, then this could be rewritten as f of a plus b minus x over f of a plus b minus x plus f of a plus b minus a plus b minus x. And so that's a really clever, neat application of the first property. You just have to realize that I can think about this entire object as some function g of x and then apply this. Okay, so let's go ahead and clean this up. So we've got f of a plus b minus x over. Now think about this, right? So here, this is f of a plus b minus x, but here, I mean, distribute the minus, right? And then combine a's and b's. That's just f of x. Okay, so we want to notice something because we want to be kind of clever. So the original integral is equal to this, right? They're one and the same. So that means, let's observe the following. So time to get clever. So just so this is crystal clear, I'm going to write this as the original integral plus itself. Okay, so whatever quantity that is, this would represent double that, right? Because you're taking this quantity and adding it to itself. So far I've got this. I'm not saying that's equal to this, right? This is a separate observation. So this sum equals the following. The observation that we want to make is that since these are equal, I could feel free to replace this with this. And then I just take note that the integral is additive, and this basically falls out. So again, the observation that I'm making is that since these are equal, I can feel free to replace this with this, right? A quantity may be substituted for its equal. So this is exactly this. Isn't that clever? So it's f of a plus b minus x over f of a plus b minus x plus f of x dx. But since the integral is additive, I have the following, right? So the integral is additive, and that gives me the big reveal. And notice I've got common denominators. I mean, this just keeps getting better and better. So essentially, since I've got common denominators, it's the same thing over itself. How cool is that? But that means I'm just integrating one, right? So this is equal to the integral from a to b of 1 dx, and that's equal to b minus a. But remember, this was equal to 2 times the original integral because we added it to itself, right? So just note that this is the same thing as 2 times the original integral. Because again, we added it to itself. And therefore, the big reveal, this integral must be b minus a all over 2. So it's been a big solving for the integral party. So quite a fun one. So don't forget to like, don't forget to subscribe, share with your math friends. More goodness on the way. If you like calculus, if you like pre-calculus, I love trigonometry. There's going to be plenty of that. There's going to be plenty of linear algebra and more proofs, more explorations, more fun, more complete courses over the years, over the months. And yeah, just stay tuned. Cool stuff on the way.